So it seems AGI is here. Before we go on, if you don't know me, my name is Samer. I'm a Fortune 500 corporate executive trying to help you do much more with artificial intelligence. So here we are again. We have one more model, one new big thing, one thing that we're describing again as being closer to AGI or AGI itself, which I think is getting silly and sillier and sillier. Well, this time I opted out from rushing into doing a review video as I used to do a lot, which is hectic honestly in these recent months. But at the same time, I thought it's not bringing the best value for you. Today I've done it differently. I've held back for 2 weeks to 3 weeks from the drop of the new O3 model by OpenAI and the O4 mini and mini high models as well. I was watching the videos and watching the reviews by people, mostly about benchmarks, which is important and interesting, but I think the vast majority of people, they want to actually see these models operate in real life. How would you experience these models in different scenarios? And I've seen some people test that. Today we're gonna go and test O3 and maybe a little bit O4 mini, but we're gonna focus on O3, the flagship new AGI type of model, at least as per what people are claiming out there, especially the OpenAI people. And today I have planned multiple tests that will really stress the O3 model's capability and should, by the end of the episode, expose to us where this model is compared to other models. At least I'm going to give you my opinion because I'm going to focus on O3, so I will not do a comparison video, but I will stress the model to the level I'll tell you, yeah, it's like different than anything we've ever seen so far, or it's better, but not that much better. And many of these tests, by the way, will be happening live in front of you while I record this video because I wanted to keep my reactions in real time so you can get the authentic version of those as well. And the only thing I'm gonna say about O3 without going to its paper is it has 4 distinct features. One, it has more reasoning capability, so it reasons around 20% more than the O1 model. 2 is that it has agentic abilities in the sense that if you give it a prompt that requires code interpreter or requires an online search, it will by its own decide the need for the use of such tools, use them, and give you the best answer. So basically, in some sense, you do not need anymore, at least with this model, to ask it to go and search the internet or do something else. It will decide on the best approach and the best use of tools that it has access to just by you asking it for the prompt or the end results that you expect out of the model. And that involves things that the model can do, again, with image, with code interpreter, with online access, and even with searching files that you might have provided the model with. And also it has a bigger context window, around 1.5 of what we had with the O1 model. So it has a 200,000 token context window. And I think it's more than enough when we consider the use of such deeply reasoning capable models like O3. And the fourth one is, honestly, I cannot put my finger on it, but people say it has a higher IQ. I don't know whatever that means. So through the benchmarks or the testing that they've done, when they take it through the IQ test, apparently it's scoring higher than any other model in that test. So in a nutshell, on at least this benchmark, it's smarter. So with this, I think we're ready to jump into the testing and we're going to see for ourselves what this model is capable of rather than just reading through the stuff. I'm sure you watched enough already, so let's just get started with the actual testing and let's really find out if this model offers anything that could be closely associated with something that we can call AGI. Let's check that out. So without any further ado, let's get started.
Subscribe to Daddy's channel. The mic.
Okay, so for the first test, I'm gonna do a geo-guessing test. People are saying this model is super amazing when it comes to these tests. Today, I have an image from a location. It's an outdoor location in my home country, Jordan, which is less mainstream. And this is not like one of the well-known places, historic places in Jordan. but it's less mainstream as a location probably than so many other locations around the world. So I'll see how good the model is in really identifying where that location is. So let's start with that. But before we just give it the prompt, just note here that now when you hit the drop down for the models, you get the O3 if you're a Plus or a Pro user, and you get also the O4 Mini and Mini High. These are the newer mini versions of the model. And it's good to note here that the only difference between O3 and O4 Mini models is that the O4 Mini models are just smaller models that are faster, more cost effective. In theory, they have really the same DNA in reasoning compared to the O3, but those models are models that you use when you have a smaller job, less reasoning requirement, and maybe something where your priority is cost efficiency and speed, while still getting that high-end reasoning capability of those models. Okay, so let me attach the image. So I have attached the image and I'm gonna paste the prompt here. I'm not gonna go over the prompts. Basically, I'm asking it to analyze the image and tell me where this location is. If you are interested in these prompts, these tests that I'm doing, write me a comment in the comment section. I'm more than happy to share it with the community. So let's hit go and see what we get out of O3 with this geo-guessing test. So you can see here, it started the chain of thought for the image. So it started analyzing the image and starting to identify the terrain. And I think it got it right. Honestly, this is impressive. Like it's nothing short from impressive. So it's giving, because I'm asking it in the prompt to give me the reasoning of why it's saying this location is that certain place. And it's even defining when the image was taken, like the period, the time period this image was taken. So the final answer, it says, this is, country is Jordan, and that's correct. The nearest city is Jerash, which is about 50 kilometers north of Amman. Amman is the capital of Jordan. That's wrong. So the image came from a city called Al-Salt, but just identifying that this is clearly in Jordan from such an image. And I'll show you again the image for you to, I mean, for a Jordanian, it makes lots of sense that this is Jordan, but this could be literally any place. If really I look at it from a non-Jordanian eye of some sort, if I show it to someone, this could be anywhere in the world, and it just says it is Jordan, and it mixed it with one city which is towards the north of Jordan to where this was taken, which is to the center of Jordan as a country. But this is impressive. So I would give it, for this test, if I'm ranking these things, I would give it a solid 9 out of 10 because it's just impressive, the fact that it got the country right. So let's move to the next test. For the second test, it's actually something I've done before myself, and I thought it's worthwhile to share with the community. It's a test, it failed, and I think it's good news that it failed. And what I've done here is I created an image on Canva, downloaded it, which is an image with clear white background and clear black text. And what I've done is I run a very simple, well-known Python library as code, and I asked it to pixelate that image for me. And then my request for O3 is if it can use its tools and kind of reverse the pixelation and read the text behind it. And it failed, which is very good. It tried actually to do it, but eventually it failed. So it is going off the image. The code itself cannot reverse at least this image directly straight from the interface here with the chat. While I know for a fact that people using some code that they run through Python in their environment or whatever, they are able to reverse some of the pixelation, which actually is a note here. Be careful if you're showing API keys in the videos you share with others. Even if you pixelate them, some people can reverse that pixelation and uncover the key behind it. Depends, of course, at what algorithm you're using to pixelate your images. So just be aware of that. So good news is the model failed to do that. So we are safe for now, because when this goes mainstream and models can reverse pixelation, you need to be 10 times more careful with what you share online from your screen. Okay, for the third test, and from here on, I'm gonna start to stress O3. I'm gonna give it a really complex chart that I will show you in a second. And this chart is part of this paper. This is a biochemistry and biophysics type of paper by the University of California, or at least the folks there. And it's a complete paper, and this chart is part of it, explaining the tree of life concept. and I want to just send the image itself and basically ask O3 to explain what's behind this image. So it has to look through this image and try to explain the idea of this paper that goes behind it. Now, it's very hard when we do these things if you know if this paper was part of the training material of this model, which could be. This is why when you look at OpenAI, they always talk about having those kind of data that is hidden from the model, data that the model did never seen, for them to validate efficiencies of these models when they do the training and they want to test it afterwards. But still, this is a good test for these kind of agentic abilities. So I will give the image for the model. We're going to see how the model handles the image, and we're going to see what it does with it, where it will start taking close-ups of this image and then trying to dissect it and understand it. And then it will bring some kind of thesis around what this image means, what it represents, what's the logic behind it. So I will give it a prompt that basically asks it to do all of that for us, dissect the image, and in plain words explain this chart for us. So let me attach the image. So we have the image here. Now we have the prompt, and let's hit go. If you're still watching, thank you very much. Do not forget to hit that like button, subscribe to my channel to support it, and write a comment in the comment section. You can see here it's analyzing the image as we look at it, and you can see here the focus is happening. So it's getting these kind of zoomed approach to the image. It's zooming at specific spots, trying to examine it. And I think later on we can showcase the whole chain of thought that it does with these kind of image extracts and see at least where the logic takes it, and then we'll question it if actually it got it right. And you can see here it's using code. So it decided to use code as part of the analysis. So that's interesting. I mean, even if it's not a perfect fit of how this model works, definitely having it pull in those tools randomly without you having to prompt them or that request into your request or your query, I think that's a big step forward. But how good it is at using those tools and their outputs and getting you a really solid reasoning response, that's something we're going to test here today. So it's even using code multiple times, and then it's doing some kind of analysis. Then, okay, birth, transfer, loss, okay. So starting the breakdown. So key message, life's family tree isn't just branches, it's a web of gene sharing. I think it got it right. Why it's significant? The overwhelming green tells us microbes consistently swap genes, and then blurring classic tree boundaries, okay. Innovation doesn't equal invention. New capabilities often came from borrowing or repurposing existing genes, transfer and duplication. Early evolution was gene loss heavy. Yellow slices show many genes were shed, streaming organisms and new niches. So I honestly didn't read the paper word by word, but this is well within the realm of what the paper is addressing. But I'll ask actually get this model itself, O3, to validate if that's true or not. So here are the numbers you asked for, and basically I asked it to look at those so many pie charts and try to analyze it for me at least. So it's describing them in simple terms as I asked as well. So 60% transfer, the earliest lineage were gene import champions. 36% losses, shedding baggage was nearly as common as gaining it. 3% duplications, copying genes was rare but still meaningful. Okay, so even it's telling me how to further analyze this image myself. So here I basically gave it the paper where the image came from, the diagram, and I asked it actually rank yourself from what you analyzed the image to depict and what actually the paper talks about, and give yourself a rank from 0 to 10, 10 being the highest rank of accuracy towards your analysis compared the actual contribution of that image within that paper. Without going through this line by line, you can see that O3 actually broke down the question of how it would rank itself compared to the actual paper by breaking down the ranking to different criteria. So the first one is core purpose of the diagram, and it ranked itself very good. And then it tells us why. And it says, I called it an evolutionary phylogenetic tree summarizing gene level events across life's major lineage, etc., etc. So it got the gist of it basically. Meaning of the 4 colors criteria, it got it perfect. Time, axis, and layout, again, it got it correct, and the explanation is here. And then interrepresentation of pies, mostly correct. So here it talks about that it's stated that each pie shows the mix of events on that branch, and that area represents the count. The caption confirms area equals the number of events. I did not mention that larger pies can occur anywhere. Not so, okay, it's like something really minor, but it's not giving itself the full correct answer here, again, because it understands now the full context of that diagram. At least we know that O3 is being honest. Okay, also on the criteria of quantitative summary, reasonable but approximate. Okay, it was able to get it close enough, but it's again approximate. And then the big picture takeaway of the diagram, it's accurate. I emphasized that early microbial evolution is a web of gene sharing and that horizontal transfer dominates. Yada yada yada. So it gave itself 8.5 out of 10, which I think is a fair ranking, and I think most humans, I'm not talking about expert humans here, would not get this at all. Okay, so now for this phase of tests, it's going to be financial reasoning. So I'm going to actually do 2 things. The first one, using its tools and basically internet browsing, I'm going to prompt it to analyze the Tesla stock for me based on the recent filing of the SEC that Tesla does, or the financial statement. And I'm expecting the model to go online, grab it, and then do the analysis. And we're going to look at that, and then we're going to compare it with me actually uploading those files to O3 and asking it the same prompt, but based on an attached actual file and not just that online search that it can do. And my intent here is to compare the reasoning capability of the model based on just online browsing access, or giving it the actual data, the actual documents containing the data, and see if there's a difference. Because honestly, at some point you would love to have models that would do that search for you, get all of these documents for you without the need for you to go online and fetch them yourself, download them, and then upload them to the model. So this is the first prompt. And again here, just for you to know, I'm actually telling it, I need you to do browsing for me, and I need you to do the Python use, the code use, for you to analyze those documents that you find online and then do the analysis for me. And the ask from both prompts is the same. I am asking it to project a 5-year growth, again for the Tesla stock, show the reasoning by the model with a brief financial analysis, and include a simple chart of the revenue trend. Again, this is something that it has to do through code. And before I run this, as of today's date, we only have the 25 Q1 financial report and SEC filing on the Tesla website for investors. So we have the deck that they give for investors and then the SEC filing. So I expect the online search to look at that specific report of Q1 25 and not something older. So let's see. You can see it's doing the web search now. So it's looking at the reports. I don't see 2025 anywhere here, so seems it might not be only looking at that one report because I didn't specify it in the prompt. So it's looking at wider kind of timeline, but it should have at least reflect something really recent. Let's see what it comes back with. And you can see here now it's using the code tool, the Python code tool, to run some calculation of its own to analyze the information it has. As so far, it thought for 1 minute 29 seconds. And if you tested O1, it's clear that O3 thinks deeper. They say 20%, might be more actually, than O1. And you can see here it's giving some images, I think, from online, or it's creating it. Actually, it built it. So this is the projection, 5-year projection that we asked for. So you can see the actual, and it stopped at 24. There is 25. 25 is available. It seems that's the gap here. It couldn't find it. But still, this is good enough. If you're trading in stocks, if you want any insight into investments, today you have, with these reasoning models, honestly, the capability of being an expert investor or having your own consultant with you at all times to give you such advice. So this is the projection. Again, we know what Tesla stock went through recently. So there will be reasoning behind this. It's not the intent of the episode to go into detail of this one. I think you can do it on your own if you have access to the model. It will be interesting to read the reasoning behind it. Here it's basically projecting in billions the revenue across the next 5 years. The next 5 years are looking good. Some people, based on what's happening today in the world, it's a crazy world we live in, they might say, well, I don't think so. And you can download it, obviously, if you know that feature here. And then it looks at the net income, at the revenue, and then it has the analysis to back it up. And this is the 5-year outlook. Okay, even here at the end, and this is my personal trick. Write me a comment in the comment section if you want to know how I do it. But every time I ask ChatGPT in general something, I get this kind of source quality. I get the model to tell me the quality of the cited sources. So you can see here it got 3 sources and it's giving them a credibility ranking 0 to 10. So I got a 9, which is the number 1 ranked, and then 2 ranked as 6. So basically, I would assume that the model is prioritizing this source over the others when it's giving me its response. It's good. I think it missed 25, which could be key for the projection. So what happened recently, which is linked to politics more, US-based politics, could really affect how you would project the next 5 years for a company like Tesla based on what's happening worldwide. If you're still watching, thank you very much. Do not forget to hit that like button, subscribe to my channel to support it, and write a comment in the comment section. So let's test with the actual documents. Again, I'm going to attach the documents as per Tesla, which will definitely not include what's happening out there with Tesla. Probably it will try to shed a more positive light to things, although they have to follow the gap rules. And again, this is an SEC filing, so every number should be correct and they cannot go around it. So I don't know if the model will pick up something when I give it the actual information or documents based on the Tesla website. So let's do that and compare it to what we got here. So here I attach the actual files, and again this is the same prompt asking for the same thing. So let's hit go and see what we get now. And again, this is a new fresh window, so I don't mix two together. But with this, we will get if it actually searches as well as it analyzes documents or the other way around. We'll see. We'll have to make our judgment based on this. So it's still analyzing, and it might still go to the internet, by the way. This is really interesting because it's saying I'm looking at 1 quarter numbers, which is like focusing on these 3 months. That's not enough to project for the next 5 years. I'm going to still have to go online, and you can see it's searching the web and look for the 2024 numbers so I can have a longer period of performance so I can project the next 5 years. So honestly, this shows you like all the hype around the model, how good it is when it comes to reasoning, how good it is in actually using these agentic tools it has access to. It is not a stretch actually to judge that this is the best model out there. And you've seen all the charts. If you're interested, I can share some in the comment section. I can pin it to the first comment. But if you just search online, you're going to find all of these charts topping O3 as probably the number 1 model out there, especially when it comes to reasoning. Coding, still I think it goes to Gemini 2.5 Pro, but O3 is definitely a big player when it comes to the reasoning and how smart this model is. And you can see it also used code to do some calculations and actually run the chart. So this is a different chart altogether. This has 2025 actually accounted, but let's see here. So here it at 2029, it is calculating that the revenue in billions will be more than $140 billion for Tesla. If we go to the previous one, here you can see that for 2029, actually it is closer, the revenue is closer to $160 billion. And here projections are based on 10% CAGR, so it just used a flat compound annual growth rate. So it's not really a kind of complex projection. But anyways, there's a difference of around $20 billion between the forecasting it did based on the internet search alone and from the file search plus the internet search that it insisted on doing because it needed more context to the performance of the business so it can project the next 5 years. Going back to the one it did with the file and the internet and scrolling down, you can see here the CAGR it calculated is actually 8%, not 10%. And it has actually more detailed metrics or kind of factors in calculating the forecasting it did compared to the other one. So this is a little bit maybe more pragmatic, more accurate. So I think overall this is maybe more accurate. So I did one more prompt, honestly. Did you see in the attachment anything slowing down future growth and revenue? I want to see if any of what's happening now actually was analyzed by the model or seen by the model as something going wrong, which reduced the 5-year projection by 20 billion, or this is just simply high-level estimates that it used the difference between 8% and 10% compounding over 5 years and made that difference. But I think 20 billion is too much. And here saying yes, the Q1 2025 10Q flags several headwinds that could keep Tesla's top line from re-accelerating quickly. And here it's giving all of these reasons. Price-driven revenue decline in Q1, shrinking regulatory credit opportunity, tariff overhead on energy segment, falling mega pack ASAPs. I don't know what's that, honestly. Vehicle demand softness. So it's actually getting some, it mentions the tariffs. It doesn't mention all of the political hype because that will not be in that report. Macro and financing conditions. All of these, I think, are linked directly or indirectly to the tariffs and maybe by products or impacts of the tariffs that maybe Tesla is already bracing the market. That could be an impact on the company. I think other companies will do the same. But it's interesting, yeah, it sees those kind of headwinds which affected the way this session with the documents to reduce the 5-year projection by 20 billion. Maybe someone in 5 years will come back to this video and write me a comment in 5 years from now if actually O3 got it right. By that time, probably we're going to have AGI and I wouldn't be joking about it. Okay, so for the next test, I'm going to see how good O3 is in really digesting and summarizing complex and long text. So here I'm asking it actually to look at a quantum, literally quantum physics type of paper. And this is the paper I'm going to feed it. It's quantum information conveyor belt. I don't know what the hell that is. So I'm going to ask it to summarize the whole thing in 5 bullet points. And also I will ask it, does the information that is presented in this paper by the author or authors really support the conclusion that they drive towards at the end of the paper? So I wanted to reason through the evidence and then say, yeah, the conclusion that they drove towards makes sense or doesn't make sense. So let's see firsthand O3's ability to really work with long text. You can see this is 11 pages, but this is complex 11 pages, full of equation and charts. So it's not your usual standard 11-page type of paper. This is literally quantum physics. So I have attached the paper and this is the prompt and here goes nothing. Actually, it took it 6 seconds to just go through the whole thing. So maybe I gave it an easy example, I don't know. So the concept and the criterion, so it's explaining the concept of the paper. The authors introduce a quantum information conveyor belt, a set of spin. Okay, so I'm not going to go into the details. So this is talking about qubits, and which is the quantum computing type of bit that is different from the bit in normal computing. Again, all of this is complex things. It looks at the results of certain calculation. It looks at the key result number 1 and number 2 here. And then it goes through the entanglement dynamics. Again, all of it is something that way too complex for me to even try to explain to you. But at some point, I'm just looking at this and reading it. And I did some reading in the paper. It seems to me that it's getting it right. Now, how good it is actually to summarize this in 5 bullet points, maybe it's over my head in terms of judging this, but let's look at the kind of a judgment request where I ask it to look at the conclusion and link it with all the evidence that the authors have presented, and does it make sense, the conclusion that they drove to. So it looks through different aspects. So I didn't prompt this in there. You've seen it's a very simple prompt, and for each aspect it's looking at strength and then gaps and needed follow-ups, which is super interesting. So it's challenging people who are doing research around quantum computing. Good for you, O3. So analytical rigor, closed form expressions for antenna density matrix, QFI and negativity provide a clear Testable theoretical framework, excellent. Non-numerical simulations to confirm scaling. So it's giving these kinds of the gaps. Okay, I will not go through this one by one. If you're interested, please write me a comment in the comment section. I'm more than happy to share this with everyone on my YouTube through the description. I'll put the link there. Let's look at the bottom line. So the bottom line, the mathematical evidence with the model supports the author's conclusion, but those conclusions are conditional on idealized assumptions. So not even standard assumptions, idealized assumptions. So not purely accurate, the way I understand using the word idealized. For a thorough assessment, one would need numerical simulations, experimental parameters, budgeting, and then error analysis, and lastly, extension to other interaction graphs. So basically, it's not satisfied with the paper and how it drove to that conclusion. If you know anything about quantum computing, if the paper is familiar to you, do you agree with the author? Maybe someone out there is a better judge of this response than me. Actually, I might actually just go ahead and put this in the description, and I will let you go through it and be the judge of how good the analysis is of this paper, and if really it summarizes it well, and if it actually critiques the author's derived conclusion out of the evidence presented in that paper. Maybe someone smarter than me can do that for us. If you're still watching, thank you very much. Do not forget to hit that like button, subscribe to my channel to support it, and write a comment in the comment section. Okay, I know people test O3 and other models exhaustively with coding. I have my own tests. There are 3 I'm gonna run today. One, just to test its capability overall, which we will judge. The second one looks at its ability to do graphics. When I say graphics, like diagrams, not graphics like games. And the third one is not to do with anything that I'm going to show you. I'm not going to run the code. I want to see if the model actually can run long context of code without cutting off. This was a big problem with O1. In O3, they say, at least I've seen people say that this is less of a problem. I'm going to honestly stretch it to the level that either it's proven that this is not a problem anymore, or it's still a problem, but okay, for really long code, if you ask for too much at one go. So this is the first prompt. I'm gonna let it go, and for us to judge it, we'll not go through the code obviously. I'll just take you to the actual run of that code on Replit, and if there's any error, I doubt we're gonna get errors from what I heard and what I read online, but also I'm gonna show you how good really the game is that this is actually requesting in the prompt by giving us this 8 match or 8 pair type of matching memory game. Okay, so as you can see, I run the code, no errors. The game started. Let's open it in full screen and see if it's a good one. So I have a counter for moves. It's called memory match, and I can reset here. So let's click this. Yeah, it's a nice image. Click this. Okay, it resets. Let's do this and this. Okay, it's using emojis. I get a guitar, a diamond. I get this and this. It matches. And it stays. I get this and this. No. So I get now this. Oh, the dog is here. Okay. Diamond. I think I've seen the diamond here. Okay, so you get the idea. I think it's good as a one prompt game. Maybe you can throw this on your website to get more people to visit it, I guess. I think it's really good. And the images it selected, honestly, are good. Definitely above average from a single prompt. So the quality is high. Hopefully in the future it will be better. I think the UI is an area where you need much more experience in vibe coding to bring something that looks really professional. But this honestly is really good from thinking for 6 seconds and a very simple high level prompt. Now for the second test, I'm going to actually ask it to look for something called the sorting process algorithm and try to visualize it for us. So this takes understanding the concept, breaking down the logic of how would you visualize such an algorithm, and then actually building the code for it. So for us to see how well that is. And just to give you an idea before we actually prompt it, the sorting algorithm or sorting process algorithm looks something like this here. So it's just bars of numbers where the algorithm will go through the values and try to do swaps until it sorts it in a certain way. So smallest to biggest, biggest to smallest, and vice versa. An algorithm that is used in different areas. And I just want the model here to create code that shows me or others the visualization of how all of this works. So again, here's a prompt explaining the sorting algorithm or sorting process algorithm and asking it to create an HTML, CSS type of visualization for this algorithm that showcases how that algorithm works. So let's see how that actually ends up in the visual that I will run again in Replit and show it to you. Okay, so we have the actual visualization looking, so you can see it's comparing, swapping, and the green is sorted. This is impressive. I mean, don't tell me this is not super impressive. So here, the algorithm actually in visual manner is going at each value, and here it's represented by a bar, it's like a bar chart, and it's sorting it from basically smallest to largest. And again, it gave it a color coding, so green is sorted, and basically if you see there's a slight red that happens in the middle, and this is what's being swapped, and the swapping is happening so super quickly so we can see it, and then it did the whole thing in front of us. This is nothing short from super impressive. It would be interesting in the future. I might do it on my own or show you to compare it with what other models build, but I don't think it will beat this. Maybe Gemini 2.5 might be close or a little bit better. I don't know. I'll have to test it to really make a judgment, a fair judgment at least. Now this is for coding, is the last test. And the intent here, unless it does it successfully, is not to run the code, but see how far it goes before the session breaks. So it stops basically generating code. And if you see here, I'm asking it for an end-to-end personal reading tracker. It's a web application with front end and back end, and I'm asking it to do everything in one go. So I'm gonna hit it and we'll see if it really runs the whole thing in a one go or it actually stops or abruptly stops, which is okay, by the way, if it happens. This is just testing its ability to publish or push long lines or numerous lines of code at once. But usually if you do this kind of thing, you'd better ask it to provide you the inputs in parts so you will get them accurate, clean, without any issues. But let's see what we get. I mean, this is just to stress test O3 and the claims that it solved so many problems that used to be there with O1 and other models. And here we go. And indeed, I was able to break O3. So it thought for 8 seconds and it stopped. And you can see it started giving some code, and then the rest of the files or the code was given in normal text, and it's all issues, like nothing here that you really can use. Then it went back into giving some Python code, and it's just parts and chunks of things. And then I broke it basically. This long prompt, which is asking front end, back end, you can see it's not what you would expect from an O3 level model, and it stopped here. You can see here it was part of doing something and it abruptly stopped. So it failed actually. It didn't solve that problem. You would expect from future versions of the models to tell you, hey, this is a big request, I'm going to give it to you in chunks, for example. But actually here it caved to the pressure and provided some type of gibberish and nonsensical response that you see here, and eventually it stopped. It abruptly stopped and didn't really think for long. It thought just for 8 seconds. So it's about the pressure to kind of publish or push forward such amount of text breaks down the O3 model apparently. It does for other models, not the Gemini 2.5, by the way. I've tried it myself. I gave it huge context. It still delivered. If you overdo it at some point, it will start hallucinating, but it will deliver. This one just collapsed. Now, this is the last test, and this is the only one where I'm going to read the prompt because I think this is important. This last test will check the model's hallucination or hallucination tendencies. And just for you to get how I'm going to do that or how I'm going to determine that, let me read the prompt and then I'll explain. So you are an academic research assistant. The task is list exactly 5 peer-reviewed studies published 2022 or later that investigate AI hallucination. So basically, I'm checking hallucination through asking it to deliver papers on hallucination. False or fabricated output from large language models, explaining what a hallucination is. For each study, provide a full APA citation, including the DOI, a digital object identifier. And again, there's basically an organization that does these identifications for these objects. So any digital objects, there's an identification used for tracking across different functionalities. It is something I'm not so familiar with, but it's something that I came across while researching how can I really check the hallucination of a model? And these things came up. So in 2 to 3 sentences, summarize the paper's main findings on hallucination frequency, causes, or mitigation. Rank the studies from most to least rigorous based on the sample size of the methodology, and explain the ranking in one short paragraph. And here's the important part. Important: do not invent citations or DOIs. Supply only references that can be verified. If you are uncertain about the DOI, say DOI not found, low confidence, rather than guessing. Think step by step, but output only final answer, not your private notes. So I'm asking it to literally cite and give me something based on a document or an object I can verify through the DOI organization. So once I get the answers here, I will go and look this digital object identifier for the paper it cites and really check if that paper is actually talking about hallucination or something else. So that will tell me if it actually talks about hallucination and the answers it has really somehow seem in that paper, then we say hallucination is really limited here. This is what they claim for O3. But if it's not, if it talks about a totally different paper or it doesn't exist, that could identify that it is hallucinating. So it's a hit and run type of test, but I thought still it is worthwhile to test with you. I didn't test this before. So here goes nothing again. So let's push it and see what we get. If you're still watching, thank you very much. Do not forget to hit that like button, subscribe to my channel to support it, and write a comment in the comment section. So here you can see it's reasoning through the approach, what it needs to do. Probably and surely actually it will go and do the search for the web, and you can see some of the best archives for papers is already part of its radar. So you can see here, it's looking at different libraries. So let's see what it comes back with. Okay, so we are getting the result. And now peer-reviewed studies on hallucination in large language models between 2022 and 2025. So we're getting all of them here. And we are getting the links for the digital object identifier. So you can see it's actually linking the DOI through the DOI organization. And again, if you don't know that concept, look it up. It's really interesting. And apparently this part here, this number, this is the DOI, probably including this one, for this actual paper that we see here. So here, for example, they cover this paper that talks about GPT-4, and here they're talking about hallucination of some sort. So this is just summarizing in sentences. Here in this part, they're talking high entropy predicts hallucinations with 79% accuracy, yada yada. Okay, so let's start with this one. Let me click at this link and see if it takes us to the actual paper. So let's click here. Open link. So detecting hallucination in large language models using semantic entropy. So this is a link that actually goes to the paper that talks again about ChatGPT or Gemini. Okay, so this is at least the title of the paper. So we can see here Yaren Gal, so this fellow, okay, and Jenek Kosen. If we go back to what we got, so you can see the names here, Gal and Kosen. So it seems it is the actual paper. So it got the first one right. Let's do one more just to see the accuracy of, actually it got the digital object identifier for all of them. So let's look at this one, which talks about Cove forces a model to draft an answer, post fact check questions, answer them independently, and then revise. Okay, so it's just a methodology of reducing hallucination, I assume. And this is the chain of verification reduces hallucination in large language models. Actually, this sounds interesting. I might do my own study and video about it. But let's go to this DOI item or object to see if this is the chain of verification and reducing hallucination paper. Open link. And it is the chain of verification reduces hallucination in large language models paper. Honestly, this is impressive, and if it tells you anything, it tells you that this model's ability of getting high quality cited sources for the queries that you give it is really impressive. And again, I just want to show you something that I will answer if you put enough comments in the comment section. You can see automatically all of these requests that I give ChatGPT, always I get this section. And here it is ranking how well the sources that are cited are. And it's giving them from highest ranking, so most reliable to least reliable. So this is something I've done in my ChatGPT to really achieve this. So every time I exchange with ChatGPT where it goes online and gets me something, especially now with O3, I have a definite answer at the end telling me it's something to further cross-check. Usually it's recommended to do that, or something at a high ranking or high accuracy that I can just take the risk and go with, which from what I'm seeing so far is a bet that I might be taking from time to time, because this is getting more and more accurate. So this is it for today. I did 10 different tests for O3, the May 2025 flagship model out there, apparently. Not AGI, if you ask me, but definitely one of the best. Probably not in every area the best. In reasoning, I would clearly give it a number one. When it comes to coding in other areas, maybe Gemini is still a close second. But when it comes to reasoning, I don't think there's a reasoning model that matches O3 out there today, at least. And I hope you enjoyed the latent testing that I've done. So if you prefer this rather than the quick on-the-spot kind of review of a model and going through the OpenAI documentation and benchmarks, please write me a comment in the comment section. I would actually spend more time to give you more quality content rather than going crazy and trying to go out of my way to give you something on the spot when the model just came out, and rushing with every other creator to show you all about what they are showing on their website, and rather take a step back, kick back, see what others are talking about, do my own testing, and on my own pace give you something at this depth and wealth in terms of testing and reviewing of such a model. So thank you for sticking around so far. I hope you enjoyed the video. If you did, do not forget to hit that like button, subscribe, and with this, thank you and goodbye.
Subscribe to Daddy's channel. Give me the mic.